Hello, everyone. Can you all hear? Hello? Can you hear me? Hello? Hello, hello. Can you hear? Is camera on? Audio? Check, check. Check, check. Good. Excellent. Well, welcome back. It's been, feels like a vacation of some sort. We haven't been on the air since 2 weeks. Okay. In fact, I actually blew out my Mac a few days ago, so I had to reinstall everything. It's fine. I mean, I got a nice clean PC now, so I wasn't sure. So I had to redo everything all over again. I had to reinstall OBS, I had to reinstall Zoom, all the templates. I mean, it took like an hour or few, but it was still work. Anyway, well, welcome back. It feels like a vacation. I'm Ming Chow. I'm Associate Teaching Professor at Tufts University, and today we are back on Twitch Live, and we're going to spend today talking about static analysis and static analysis tools. I don't think today will take the whole time. Um, the intent is not to spend the whole time. There's going to be more demos than anything else. So, for the last couple of weeks, students have been playing Capture Flag. Students have been playing Capture the Flag in my security class. The game is over. Hope everyone had fun. Hope everyone had a blast. The teams did really well. I always nice to see students having a lot of fun playing Capture the Flags. But it's not over yet. It's not over yet, and because I released the source code of the entire CTF game, and it's now trying to do a technical risk analysis and static analysis on the entire game. So just a quick review what static analysis is static code analysis is no execution of the code, no execution of the program, and full 100% code coverage. Okay, so last time around, for those who are not familiar, who were not in class on Tuesday, we showed one example of a vulnerable piece of source code. Just a quick review. Here is a sample piece of C code and spot the vulnerability. And if you mention that, you know, the buffer size is a little bit too small, that's some credit. But the real problem is with this piece of C code is the use of one of the dirtiest C function, better known as stir copy. Stir copy, you're trying to copy in anything from the command line argument into buffer underscore 2, which is of length 8. So the end result is a classic buffer overflow. I'll just run this again. So they do vuln, and I just type in 4 A's. Okay. So far, buffer underscore 1, no issues there. Value, no issues there. But what if you were trying to, let's say, write a fuzzer? And fuzzers are used to detect, to find buffer overflow vulnerabilities. You write a fuzzer, and you just feed in all kind of garbage to try to crash the program or make it segfault. But now this is where the issues. Now we have a problem. Copying 8 bytes into buffer underscore 2, and you can see buffer underscore 1 is now being affected. What happens if I have a whole ton of A's? Ooh, and now you have not only buffer underscore 2 being affected, but buffer underscore 1 has issues, and also values. You take a look at what value is, which instead of being 5 is some wonky value. This is a classic example of buffer overflow, but the root cause of this problem really is, the use of one of the dirtiest of the dirty C functions, stir copy. It's also my time to give a shout out to Gary McGraw. Back in 2004, when he introduced me to security, this was one of the first lessons I learned from him. And also, we got into a flame war about why Java is perhaps more secure than using C and C++. Okay, so here we are. We have a problem with stir copy. But let's move on and let's do a few examples. Anyone a Java buff here? Anyone Java buffs? Let me show you a piece of Java code now. Now, what I'm about to show you is Java code. But even if you don't know even if you're not familiar with the Java programming language, you should be able to spot a number of different vulnerabilities. I'll show it to you. There we go. That's it. Here's a piece of Java source code. It's a class called Twitter test. So, find the vulnerabilities. I'll give you a few minutes. Show me the vulnerabilities. I'll give you a few minutes to take a look at the source code as is. You have SQL injection. Yeah, Ray, feel free to just ask the question on the message. Spot the vulnerabilities. How many vulnerabilities are you finding? I guess that's another question. I mean, you can make a count. Yep. Okay. There's a whole number. There's a number. There's at least, there's greater than 2. Quite a lot of vulnerabilities here. Anyone else want to chime in? Yeah, I think that's the best answer of them all. This can't get any worse. But what's what's sad is here we are in the year 2021, and people make these same mistakes all the time. I do not work at a FANG company. I do not work at Facebook, Apple, Amazon, Netflix, or Google. No. Have not, and have will never will. Okay, so there's a number of vulnerabilities here. In fact, huge, some really glaring ones. Some really glaring vulnerabilities. So number one, the most glaring one, is the hard-coded username and password. Hard-coded username and password. That's bad. I mean, that's just a 6-alarm fire out of a 5. Now that's number one. Number two, you have the query here, which is string concatenation, which is the select statement. I mean, that's SQL injection, just asking for SQL injection. That's number two. So we have 2 glaring issues here. Hard-coded credentials, the concatenated strings, this query built on string concatenation. What else? Here's another one. The other glaring issue is when the username is root. You have a least privilege problem here. So if you're using a username that is root, guess what happens is that you're logging into, in this case, a MySQL database as root, you get privileges to all, to everything. So you have a least privilege problem here. The other things are there's a huge code quality problem. So if you're doing import java.sql.star, I mean you're importing everything. Only import the stuff that you really need. There's also another thing here. Um, if you remember, even in a basic introduction to computer science course, when you are opening a file, what do you have to do? When you open a file for reading and writing, what do you have to do? If you're opening a file for reading and writing, you have to close the file. Now, that's the same thing for a database. If you're opening a database for a connection, you also have to close it as well too. There's no database closing here. So if you're having a number of people, so I remember from past experience, if you're writing a program, a Java program that opens a whole bunch of database connections, but you forget to close them, eventually that connection pool will overfill. So you also need to close a database connection as well too. So we just pinpointed at least 5 issues, 5 vulnerabilities with this piece of Java code. The most glaring ones are the SQL command based on string concatenation, hard-coded username and password. Mm-hmm. Okay, it compiles fine. I mean, this program compiles fine. Will it work securely? Absolutely not. Okay, whole bunch of issues. Human Horn, a Futurama reference? Yes, it is. Yes, it is. Human Horn, one of my favorite episodes. This is one where Fry got his nose cut off. One of my favorite episodes. So that's an example. This is an example of vulnerable Java code. But there's a reason why I showed you this. So, okay. So the next piece of vulnerable code I want to show you for JavaScript people. Okay. Next piece of code I want to show is vuln.js. Here is server-side JavaScript, no JS. Find me the vulnerability. No, in this source code, in vuln.js, we spot the vulnerability. In fact, I'm going to run this thing. It's going to work. What's the vulnerability? Okay. A couple of you said eval. Let's see what happens. So I'm gonna send some user input to this JavaScript server-side program. So what is it looking for here? Okay, it's a function. It's a post method. It's a request method. Is post, and it's looking for some data. Okay, let's send something to this server. Curl, to do a post request by way of curl is minus data. No input validation. Well, we have that problem too, but let's say hello, HTTP. The IP address of this playground is at 192.168.1.214. Watch what happens. So I'm going to send an HTTP post request with some data, hello, to the server at 192.168.1.214. Oh, very important. Port 3000. Watch what happens. So the server received hello, hello. Okay, let's try something else. 2 plus 2. Isn't 2 plus 2 JavaScript? Wait a minute. Hold on. Un momento, por favor. What if I send console.log hi? Console.log is a legitimate JavaScript function. To just put something to the screen. So Jax 1010, here you go. We got some JavaScript code. Did it execute? Ooh, let's try that. Instead of console.log some hi, let's do console.log request. Are we ready? I've never tried this before. Request and response are objects in JavaScript and in Node.js. You ready? Mm. Mm. Something's going on. You know, I'm going to put in another JavaScript object, not request response. But what if I do window? A window object should be built into JavaScript. Oh, no, it didn't. Because it's a server-side JavaScript, client-side JavaScript, so it's not going to spit out anything. What if I do console.log? What is an object in Node.js? HTTP? Wow, this is news to me. This is pretty damn cool. Didn't know that the HTTP object in Node.js server-side JavaScript, you see all the methods? Pretty damn cool. All the status codes. I didn't know this until now. I've never seen this before. Huh. That's pretty damn cool. All the HTTP response status code. Wow. Way cool. Well, let's kill the server. Let's kill the server. What if we did this? Instead of console.log, the left window, yeah. This, there we go. Like that. Swavy, that looks good to you? Can you SQL inject so it keeps on making connection to itself? Maybe we can do that. Maybe we can do that. But what if we try to, you can basically access a file system with Node.js and delete files or access. Yeah, we can do that. Or one of the most dumbest things that we can do is why don't we just kill the server? We can do process. Actually, hold on. Console.log process. Because process is a legitimate JavaScript object. And there is a function called process.exit, which can actually kill off the entire current running process, in this case the server. So watch what happens if I do process.exit. Bang. Server shuts down. And empty reply from server. Okay. You take a look at this again, and you take a look at this piece of source code again, and the reason why we are having, well, why the server behaves the way it is because, yes, as everyone has figured out here, because of the eval function that's being used. Um, eval, what it does is that evaluate a string as code. And there's an old saying that, eval is evil. Okay? So, I showed you three examples of source codes. I showed three examples of vulnerable source code. Uh, Vuln.c, this one has a stir copy problem. Vuln.twittertest.java, you have a hard-coded username and password. You have SQL injection here. And of course, Vuln.js, you have the use of an eval function. You have an eval function. So what's the point am I trying to, why did I show you all three of these, why did I show you all three of these vulnerable pieces of source code? They all have vulnerabilities. They all have some glaring vulnerabilities. You can identify them with your own eyes because these programs that I just showed you on the screen are pretty damn short. But, but what if you're working with a large code base, with an extremely large code base, such as an iOS app or an Android app, or if you're working with millions of lines of code? I mean, you're not going to be able to just, use your eyes and just spot all the vulnerabilities just like that. You can't do that. So the tool, and if you're a software engineer, software developer, whatever you want to call it, one of the most important um, tools that you should be in your tool chain as a software developer is what is called a static analysis tool. And there are many, many, many static analysis tools out there. What a static analysis tool is, analyze your code um, or your binary uh, for glaring vulnerabilities. For glaring vulnerabilities. You want to do it automated. And what's really important, I'll give you a few examples of static analysis tools. At the very simple one, you can write a static analysis tool yourself using like Python or even a shell script that all it does is just grep for insecure function and just really ugly function like eval or stir copy. I mean, that's a real simple example of a static analysis tool, a code checker tool. There's also open source projects and also commercial static analysis tools that are available, which I will show right now. So one of an open source version, an open source static analysis tool is called Infer. Infer was created by Facebook. So FB Infer. Free and open source project. What it says right here is a static analysis tool for all of you. It only works for Java, C, C++, or Objective-C. And what Infer does is looks for things like no pointer exception, resource leaks, annotation, readability, locks, race conditions, you name it. It's free and open source, but it only works for C, C++, iOS, and Objective-C. So, okay, so are we not using static analysis tools in the lab other than that point, right? Yeah, I mean, you can do it with your own eyes, but to, you'll be foolish to not use one. You might want to get into the habit of doing so. And the reason why I made the static analysis option kind of extra point, what made it extra credit was uh, students in the past usually get the message too damn late. Using Infer, here's the documentation. You can even have a Docker container. Okay. It takes a while to install. It took me, even on a good machine, it takes like 20 or 30 minutes to install. Okay. All right, so that is a free and open source version of a static analysis tool. If you are into JavaScript, there's another project called Flow. It's a static type checker for JavaScript. And a static type checker is a type checker and an example of a static analysis tool. Cool. All right. So there's another big reason why static analysis is so important to talk about, especially for this generation of developers. Are we supposed to use any other tools for it, or own I? Usually both. You want to do both. What are you calling? If you're familiar with GitHub, if you're using GitHub, this was early last year. GitHub recently have been integrating static analysis tool into GitHub repositories. So I'll send this link out. There we go. So third-party scanning tool, static and developers training. So you can incorporate a whole bunch of different commercial static analysis tools in your pipeline, your development pipeline now. Synopsys, Veracode, you name it. Okay. So also, moreover, this is really cool. Code scanning is now part of everyone's tool chain. Code scanning is now part of GitHub, and for you can incorporate this. Yeah, CodeQL, semantic code analysis engine, treat code as data, allow you to find potential vulnerability with greater confidence. You name it. Yep, did I post that in? Great. Yeah, code scanning is available for each and every repository. So I'll show you an example of how code scanning find, triage, fix vulnerability for existing problems in your code. Code scanning also prevents developers from introducing new problem. You can schedule scans, you name it. All right, so here is an example project. You have to log in first, which I did. I logged in. I'm logged in. But where you have to go to is to go to security. Here it is. Go to the security tab of your project, security overview, code scanning alerts. Boom, make it active. Automatically detect common vulnerabilities and coding errors. I'm active, view alerts, which I find this is BS because I know there's a whole bunch of vulnerabilities here. No code scanning alerts found. Boom. You can also set up even additional code scanning tools in GitHub. Get started with code scanning, detect common vulnerabilities and coding errors, and you can actually even add any one or many of these into your workflow. Oh yeah, I forgot you were on 120. Fun times. Fun time. Doing it again this summer. We're doing it again this summer. You can even have Veracode static analysis, synopsis, fortify, you name it. So now the whole idea, the big idea of static analysis is also tied in with GitHub. They're also tied in with GitHub. This also you can set up security policies as well too. How to define how users can define how users should report security vulnerabilities for this repository. So that goes back a few weeks of what we talked about with security vulnerabilities. All right. So static analysis can be tied in with GitHub projects. Whether you're a paying customer or you're a free customer or you're not paying anything, it's available for everyone, which is really cool. I'm gonna log out. All right. So what is this? What about other commercial tools out there, such as like Veracode? Okay, which is like Veracode. Um, hold on. Let me see if I can get this in. Hang on. Timeout here. Veracode is because if you upload, everyone can see your code. Yeah, that is a problem. Hang on for a second. Let me just. Get the. I keep on forgetting. Uh, Timeout. Uno momento, por favor. I'm gonna log in as me. Paste the password. I'm gonna log in. So it's analysiscenter.veracode.com. Veracode is based out of Burlington, Massachusetts. It was founded by um, a couple friends and Chris Weissoppel. One of them was Chris Weissoppel, who's one of my mentors. So I want to give a shout out to Chris and his team at Veracode. And I want to thank him for supporting me for all these years. In fact, Veracode is a commercial product. It does cost a good chunk of change, but since fall 2013, Chris and his team has given this class a free license to use Veracode. Yes, been for all these years since fall 2013. So thank you so much, Chris, and to Veracode for your support for all these years. Go back a long way. So I'm going to log in and give you a nice free surprise. And here it is. Here's my dashboard on Veracode. So if you yeah. So if you log in, didn't know it timed out. Huh. Here are all my applications that I have on my dashboard. So what you can do is, if you want to start a brand new scan, you can say brand new scan, you can click a new application, you can even do an existing one, but you want to usually check a brand new application, name the application that you want, pick a policy of your choosing, yada yada yada, pick your organizational unit. So here's the deal, and then you hit save and continue. Then the next thing is, then you just upload your binary or your source code. You can either choose one or the other. If you upload a binary, it's going to be reverse engineered to be source code. You upload source code, including like a zip, which is like the capture the flag game. That's fine. And so what students do in the security class is they just upload a zip file of the CTF game. And so what ends up happening is they just upload it. Sometime, now here's a warning. When you send stuff to Veracode to analyze, it could take anywhere between 3 minutes to 3 days. Sometimes you say, okay, we'll get back to you in 3 days, and you actually get your results back in 3 minutes. Or sometimes you say, okay, we'll give you 3 days, but then you actually take 6 days for the analysis to happen. So I'll show you an example of a completed project that was done. So it depends. It really depends. So let's take a look at this project, Groundwork Somerville. This is a senior capstone project for this academic year. This one is not a good project to show because it has a score of a 99 out of 100. So that means it looks like it's pretty damn, well, quote unquote, secure. But you take a look at the result, let's see what happens. No very high issues, no high issues, no medium, one low, one no very low, couple informal. Just information leakage. Not too fun. Not too fun. What about the predicting and modeling unemployment US rate? This one got a 98. This one's not too good either. Well, go to results. They got no very high, no high, couple medium issues, all cryptographic issues, low, very low, you name it. That's not so good. This one's not a good example. We want to see one that actually has problems. What about this housing help problem? Another senior capstone project. Ooh, this one got a 92 out of 100. Okay, the lower score, the better it is. So that also means we have better, much better results. Ooh, this one gets interesting. No very high issues, no high issues. 22 medium issues. Let's see what they are. So let's go to view report. And I want to thank this team for being good sports. This is awesome. So what are they? Authentication issues, 14 CRLF injection, 4 cross-site scripting, 3 cryptographic issues. And you can go to the policy control. You can now go to the find. You first start off with this is the executive summary tab. And let's go to findings and recommendations. Go to the medium. Authentication issues. Give you a little description and recommendation. Cross-site request forgery, CSRF, CWE ID 352. Description, recommendation, and also the location of the vulnerability. Now, this is the one thing about static analysis engines. They're going to tell you where the vulnerability is in the source code, the precise source code file and a line. But it doesn't prove the exploitability. It doesn't prove that. It doesn't provide a proof of concept or proof that this vulnerability can be exploited. It's just going to give you like a ranking. So that's what static analysis will not do for you, is to show you the proof that this is an exploitable vulnerability. Static analysis will not do that. It will only show you what the vulnerability is, where it is, and potential of exploitation. It won't actually do the exploitation. You want to actually do the exploitation, that's with dynamic analysis, which means actual running of the code. Static analysis, no code, execution. Associated flaws by CWE ID, this is CRLF injection, and you can see a whole bunch of issues. Source code file, line number. Exploitability, likely. Cross-site scripting, the most famous improper neutralization of script-related HTML, ELA tags, and a web page, basic CWE ID 80. All the file, location. Okay. Well, this one got a 92. All right. So, Victor, you're on the line here. Victor, you're here. Victor, mind if we see your report? Victor? Mind if we take a look at your report? Let's go for it. All right. So Victor, here we go. Victor, you sent your submission. Let's see how it is. Ooh, we got a 77. That's a bit higher than I thought. I was fully expecting like a 50 or a 40 out of 100. So 77 is kind of low. Take a look at the activity law. Let's go to the results. Did you take a look at the results yet? Ooh. Open flaws severity. One very high, one very high, 8 high, 39 medium, 4 low. Not good. Not good. But for learning, it's fantastic. Top risks: SQL injection, code injection, cross-site scripting, credentials management, cryptographic issues. Lots and lots of flaws. Lots of flaws. So you have a whole bunch of open issues. Now, of course, in our security class, in this class, you don't fix the problem. Don't do the remediation. The only most important thing is you just want to get a report of what the vulnerabilities are. That's it. So I want to say thank you so much, Victor, for being a great sport. Thank you so much. This is really, really good. So Victor just uploaded the CTF game from last week. Let's review the report. Here's the executive summary again. You've already seen this. One very high, one code injection, 8 high, 8 SQL injection, a whole bunch of medium issues. Bunch of information leakage, but let's go to the findings and recommendations. Very high problem. Code injection, one flaw. Improper neutralization of directive in dynamically evaluated code. Eval injection. I think this must be the GameStonk terminal. CWE ID 95. Then there's source code, the directory of where the source code is, index.php, line 13. Likely exploitable, which it was, by the way. Alright, found a whole bunch of SQL injection. CWE ID 89. Oh, here's a list of all the source code files and their location. Code injection. Credential management. Ooh, look at this one. Here's a 5-alarm, 6-alarm fire. You've seen this one earlier. That's one of the reasons why I showed that Java example. Use of hard-coded password. A good static analysis piece of software will pick out like the more glaring issues like hard-coded password. CWE ID 259. Yeah, that WordPress in the game was a really, really, really old version of WordPress. Hasn't been patched for like over a year. So, of course, yeah. So, good static analysis tool will find all the glaring bugs, all the glaring vulnerabilities. SQL injection, CWE ID 80. Yikes. Lots and lots of cross-site scripting here. Also exploitability. Alright, Victor, you got until April 8th to fix all these problems, which is today. Or maybe yesterday. Yeah. Cryptographic issues. Broken or risky cryptographic out. Okay, interesting. CWE ID 327. And a bunch of information leakage, such as source code disclosure, browsable directories, log files, unfiltered backend messages, exception traces, server information message transmission of uninitialized memory and containing sensitive data. I found a bunch of those too. So, good static analysis engine will find all the glaring issues automatically for you. And that's, yeah. So, Victor, thank you so much for being a good sport. Thank you so much for allowing us to take a look at your work and ultimately what a good static analysis tool like Veracode can provide. So, there's a reason why I'm covering static analysis today. Because it is going to be used, static analysis will be used for the next topic. And the final big topic of this course, malware. Yes, malware. The last big topic of this course, and which there is a lab for it. So that's all for today. Nice and short. Hope you enjoyed it. Hey. Thanks again, Victor, for being a great sport. And also a shout out to Veracode as well too. Thanks for tuning in, everyone. Thanks for tuning in. Yeah, but WordPress got lots of vulnerabilities. Lots of vulnerabilities with WordPress. Yes. Cool. Nice and short today, even under an hour. Under an hour. And I can log out. Oh. Oh, one note, if you're actually doing static analysis for the lab, you are allowed to upload anything that you want, like any programs that you want to try out. Also, one thing that I used to do, which I don't do anymore, I used to, after the course is over, delete all of the user accounts on Veracode. That turns out to be a bad idea because a number of students in the past actually will need it again for like when you take senior capstone. So now, when you have access to Veracode, like, yeah, you can use it for any project that you want, even outside of coursework. Cool. And so that's that. Take care.